Okay, let's start talking about quadratic functions. In the past, in previous sections, we have talked about this form of a quadratic function, and this is called the general form. We're going to talk about it more on another page. You know, whenever you graph a quadratic function, you get a parabola, which is a U-shaped graph. Parabolas are pretty special. They have an axis of symmetry that goes right through the middle. It's called that because it's symmetrical about this line, meaning it's the same on the right as it is on the left. Where it crosses the x-axis is, as always, the x-intercepts, and then where it crosses the y-axis is called the y-intercept. You also have a vertex, which is either the lowest or the highest point of your parabola, depending on if it's opening up or if it's opening down. Okay, we're going to talk about all of that in this section. So before we go too much farther, let's talk about the vertex form of a quadratic function. This is your vertex form. In this form, your a, whether it's positive or negative, will tell you whether or not your function is opening up or opening down. The point HK is going to represent your vertex, and then the axis of symmetry is x equals whatever the x coordinate of your vertex is. So let's just look at an example. Using this function, we want to answer each question and sketch the graph of the function. Does the parabola open up or down? Well, if you look here at your A is positive, which means it opens up. What is the vertex? Well, remember in the vertex form, your vertex is the point HK. Keep in mind there's a minus here, so it's always the opposite of whatever that says, and then exactly whatever this says. So the vertex is going to be the point 2, 3. So the point 2, 3, if we were to graph that, oh, I went the wrong direction, 2, 1, 2, 3 would be here. The axis of symmetry is x equals the x coordinate of the vertex. So your axis of symmetry is this line here, x equals 2. The y-intercept, remember to find a y-intercept, you let x equal 0. So you would have y equals 0 minus 2 squared plus 3. Well, that's going to be negative 2 squared plus 3, or 4 plus 3, which is 7. So your y-intercept is the point 0, 7. Then we're asked to find the x-intercepts. To find the x-intercepts, you let y equals 0. So we have 0 equals x minus 2 squared plus 3. Well, let's go ahead and subtract 3 from both sides. So negative 3 is equal to x minus 2 all squared. Now we're supposed to get rid of that square. So we take the square root of both sides. Don't forget plus or minus. So we get plus or minus the square root of 3 is equal to x, that's a negative 3, x minus 2. Now what do we know about the square root of a negative number? It's imaginary, that's right. So can we graph on this coordinate plane an imaginary number? Since we can't, we know that there are no x-intercepts. So we have to figure out what our graph is looking like from here. Well, if this is our vertex and the y-intercept is here, it is mirrored on this side of the axis of symmetry. That means you can sketch your graph and be done. Okay, how about the general form of a quadratic function? To get the vertex, you could put this into vertex form, which we're going to talk about, I think, on the next page. If not, it'll be the next page. But you can also use this formula, x equals negative b over 2a, to find your vertex. That will give you the x coordinate of the vertex. Then you substitute it back in to find the y coordinate of the vertex. So let's work a problem and see how this one goes. We're using this function to answer each question and sketch the graph of the function. Does the parabola open up or down? Always look at A to tell you if it opens up or down. A is positive, so it opens up. What's the vertex? Well, to find the x coordinate of the vertex, you do negative b over 2a. Negative of a negative b, or negative 4, over 2 times 1, a is 1. So we're going to have 4 over 2, which is 2. To get the y coordinate of the vertex, you substitute that back in. So y is equal to 2 squared minus 4 times 2 plus 7. So we have 4 minus 8 plus 7. 4 minus 8 is negative 4, and negative 4 plus 7 is 3. So the vertex is the point 2, 3. The axis of symmetry is the line, the vertical line, that goes right through the vertex. This is the line x equals 2. Remember, it's the x coordinate of the vertex. To find the y-intercept, remember, you let x equal 0. So y is equal to 0 squared minus 4 times 0 plus 7. Well, that's just 7. So we get the point 0, 7. What are the x-intercepts? That's where you let y equal 0. So we have 0 is equal to x squared minus 4x plus 7. Alright, so now we need to solve a quadratic equation. That means we need to factor it, or we can use the quadratic formula. Are there factors of 7 that add up to negative 4? I don't believe there are, which means we need to use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So we end up with negative of a negative 4. That's going to be 16 minus 28 all over 2, which is 4 plus or minus the square root of negative 12 over 2. You can stop there because remember, we're trying to graph this. Since there's a negative under the square root, we know that's imaginary. So there are no x-intercepts. So remember what we did on the last problem. This is actually the same exact problem, just written in a different form. We're going to mirror this on the other side of the axis of symmetry and sketch our graph. Now we're also asked to find the domain and the range of this function. This particular function continues going up, but also to the left, continues to go up, but also to the right, which means that this domain is going to be all real numbers. The range, remember, that represents all the y values. So the range, actually the lowest point is where y is 3, and it goes forever up. So the range is going to be from 3, including 3, to infinity.